In our first video, we said that enzyme activity rate as a function of substrate is known as a Michaelis-Menten curve, and that a couple of numbers pretty much define everything that can be derived from a Michaelis-Menten curve. So let's see how we get those values, and let's see how having those values enables us to draw a Michaelis-Menten curve. So if substrate is in excess, and substrate isn't limiting enzyme activity, we know how fast a particular quantity of enzyme can do its job. And that is known as the Vmax for a particular quantity of a particular enzyme. And since it's velocity, the rate of activity, we pull that value off of the y-axis, the enzyme activity rate axis. And in this example, it's 16. Now, that's what happens when substrate is in excess. Substrate isn't limiting the rate of reaction. And so what we see is that enzyme often is being limited by how much substrate is present, or a combination of how much substrate is present and how good it is at going out and finding substrate and binding substrate in its active site. So a mechanism to measure how good an enzyme is to find its substrate is to take half of the maximum rate of activity of that enzyme. So in this case, since the maximum is 16, half of the maximum is 8. That's half of the Vmax, okay? So Michaelis says that that value, that intersection between the rate at which the enzyme is at half value and the substrate concentration that allows for that half maximal velocity should be known as the Km for the enzyme, the Michaelis constant for the enzyme. And in this example, it's 5. So notice it's in units of substrate concentration. So the Km is the substrate concentration that allows half maximal velocity of the enzyme. Why is that a measure of enzyme affinity? Well, because since we know that it is substrate concentration that is limiting the rate of activity, this is a measure of how limiting it is. If it was a little bit better at binding substrate, then the enzyme reaction would be faster. If it was a little bit at a given concentration of substrate. If it was a little bit less good at finding substrate, then at that substrate concentration, the enzyme reaction would be even slower. And Michaelis tells us that this is a constant. It's the Michaelis constant, which means it is a property of the enzyme molecules. So each molecule in a population is identical to every other molecule in that population of enzymes, essentially. All made from the same gene, right? And so each enzyme has the same ability to find substrate as each other. And so, say if you were to change the amount of enzymes in a solution, that wouldn't be changing any one of those enzymes' ability to find substrate. And so this number, this relationship between substrate concentration and enzyme activity, this Km value, shouldn't change as we change, for instance, the quantity of enzymes that we put in the test tube. What about Vmax? Would that change if we added or subtracted enzyme from the test tube? Well, yes. So let's say I reduce the amount of enzyme in a test tube. I think that if you put it in terms of machines, if I have fewer machines, I don't know, stapling pieces of paper together, then given the same amount of time, fewer pieces of paper are going to be stapled together. Vmax is not really an intrinsic property of the enzyme. Vmax, remember, is for a given quantity. quantity of enzyme. All right? So if you reduce the quantity of enzyme, you reduce the Vmax. If Km is a constant, then the ability to make product at half maximal rate doesn't depend on how many enzyme molecules are present. And so the Km should not change when the quantity of enzyme changes. So how do we know how to draw a curve if we have a Vmax value? I've already drawn the Vmax value. I made it 12. And a Km. We already know the Km because we found that Km for a different concentration of enzyme. How do I draw one of these curves? Well, I know that the Km is defined as the quantity of substrate required to bring the enzyme to half of its maximum velocity. What is its maximum velocity? 12. So half of its maximum velocity is 6. At what enzyme concentration are you going to get 6 units of enzyme activity? At the Km, 5. So this curve has to pass through that point, 5, 6. Right, there it is. It's passing through that point. And then I continue my line right up. So make sure it's going through 5, 6 mark, right up to the Vmax. I can't go past the Vmax. That's as fast as this enzyme can work. And there is my new curve for the Vmax, same Km. This is the new Michaelis-Menten plot for a lesser concentration of enzyme.